So here's some exponential fun and a little bit of radical fun too. So with this one over here, we need to start with the numerator and have this negative 3 exponent applied to both of these. When you raise a power to a power, you multiply them. So this C part is going to be to a positive 15, and this B part is going to be to a negative 6. So B to a negative 6, C to a 15. On the bottom part, they're both to a negative 8. Now what you can do is use the rule of exponents that say when you're dividing and the bases are the same, you take the top one minus the bottom one. So that means we're going to have C, and then it's going to be 15 minus a negative 8. Minus a negative means it's positive, so 15 plus 8 is 23. And then it's going to be a negative 6 minus a negative 8. That means the 8 becomes positive, while the 6 remains negative. Well, if the 8 is positive and the 6 is negative, 8 minus 6 is 2. So B to the 2. I didn't even need a fraction bar, I'm done. Oh, that could be where I box up my answer. There we go. Next up, cube root. So for cube root, you can take cube root of cubes. So for example, 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed, well, that's going to be bigger than what we've even got, that's 64. So you can take the cube root of 1, take the cube root of 8, take the cube root of 27. A 48? No, that's not in the list, but 8 is. So I could factor the 48 as 6 times 8. And then we could take the cube root of 8 as 2. The 6 will have to remain inside. And then for x, well, this number right here, you divide it into the 5. The reason for dividing is because cube root also means 1/3 power. So if you have the cube root of x to the 5, that's the same as x to the 5 to the 1/3 power. And then when you raise a power to a power, you multiply. So it's going to be 5/3, or the 3 divides into the 5. So instead of dealing with fractional exponents that way, you just look at it as how many times will a 3 divide into a 5? It'll go 1 time. So there's going to be 1x on the outside. And then the remainder is 2. That means that 2 of them have to remain on the inside. Now do that with the y. So 3 will divide into 7 2 times. Oh, I didn't leave enough room for y. I'll have to go right here. So 3 will divide into 7 2 times, so 2 of the y's can go outside. Then that means there's a remainder of 1. So 1y has to remain inside. Over here, the square root of 800, well, that's not going to work. The square root of 100, that would work. But if you knew that you could take the square root of 400, that would be the best. So when simplifying radicals, it's best to factor them so that the biggest possible square root you can do will be done right away. So the square root of 400 is 20. So 20 goes on the outside. 2 has to remain on the inside. Square root of 2 is not going to be simplified anymore. By the way, if you didn't know about the 400, you could go ahead and factor this. You'd factor it as 8 times 100. Okay, square root of 100 is 10. With that 8, though, then you would have to say, oh, 8, wait a second, 8 is a 4 times 2, so you're going to end up in the same place. It's just going to take 1 or 2 extra steps. Okay, now we've got that dividing idea. This one is square root, so the index, it's called, is 2. That means it's going to cut this in half. So it's x to the 5. And because there's no remainder, no x's remain inside the radical. Just that 2 is inside the radical. Now multiply these out, assuming that you've covered complex numbers as you're supposed to in intermediate algebra. Then the first one times the first one is 12. This one times this one will be plus 9i. Now distribute the I. The first part will be 4i. And then the last one times the last one is plus 3. And then I is squared. I squared is equal to -1. So that means that this is actually the number -1. So the 3 is actually multiplied with -1. That means it's subtract 3. So 12 subtract 3 is 9. And then combine these two, the I terms. So plus 13i, and then it's done.